and I'm covering the particular subject of the network layer today. Um, Basically, talk about the network. Um, what do you call it? The network protocol. It allows computers to talk to each other. And let me just pull up some music in here. Um, so I'm gonna play some. There you go. Before I start, it was a good day today. Did what I had to do. Um, feel a little bit negative, mainly because of little interaction um, with somebody online about a particular subject, and which is good. I think it's very important. Mainly, I stream now to basically initiate a dialogue with this particular subject, computers, computer science, or mathematics, but to help me explore. Basically, the whole purpose of it is to understand how the world works. The whole philosophy behind it is that the purpose of existence is to study how the world operates, how life works. And in return, my belief is that we enlighten our soul. And that's a personal belief. It's also not my idea. It's a Socratic idea. So I didn't come up with this. It's just through the study of some of the ancient philosophies out there I've been using to overcome a lot of the problems that I have in my life. I've come to notice that it's negativity. As much as that we do not desire these things, they are very important in our development. Just take, for instance, a joystick or a touchpad. They utilize negative values, negative numbers. A battery uses a negative terminal. Negativity is a part of life and helps us to determine what is the right course of action. For example, in an aircraft, those negative values represents when you're turning left or when you're pulling upon the stick. You need values to determine to tell some computer system that your input is negative, and in this case, those negative inputs are very important in determining course in life. And I discussed that because sometimes you do feel negative, and that we have to sort of recognize that, and we have to approach difficult problems in a philosophical way, because that's what the philosophers did. They were very curious about how the world works. They needed to understand the essence of life. Why are we here? What is our purpose? We have to constantly ask those questions. That's the Socratic method, and also to acknowledge that we do not know anything. And we can also say that the people we are in interaction with don't know much. A lot of times, we have conversations with people who do not agree with our views. Nevertheless, you do know that we do not want to change people, nor can we change them. But I think it's very important to sort of look at it in a manner that's sort of different. We have to acknowledge, we have to engage, present our ideas and our core beliefs. And if they don't like it, well, they don't like it, I've also I live by the principles of the Tao and Jeet Kune Do, which talks about how a student, a student master, to be able to achieve mastery is to exhaust all notions and all pre-notions. We must go over them. Everybody is in different stages in their life. You can be talking to somebody who might be younger than you, who might be older. Different people have different views about life, how it works. They have different philosophies. And then we have to get engaged in debates sometimes. And sometimes we also have to understand that debates will lead nowhere. If we believe in something, we have to fight for it, or we have to die for it. These pre-notions must be exhausted. I mean, I personally have changed very much. I have become a better person because of it. I had to go through very difficult moments, and I also had radical views, and some had radical views. It's very sad, and I bring that up because of a recent event. One of the events was the the Nicholas Cruz incident, or the shootings. They had a different world view. They felt that they needed to do something about a particular problem. One thing that, yes, there are problems, but then my philosophy, the reason I don't act upon them, those strong feelings and those radical views, the truth of the matter is we do not. The belief in a utopia, in a perfect world, I would like to argue that it doesn't exist, and that's my claim. You cannot have a utopia. You cannot have a world with everything is peaceful. There's only peace. I do not think it's possible. Based on my own personal experiences of just living with people. I've lived with a lot of people. Some people you do not get along with. Some people you do. People, even your best friend, can have a different ideology. Your friendship will end. Just based on that, it's very difficult to attain a utopia, a place of peacefulness or happiness. There's no way. We have to look more deeply into that. What makes a human? What can make a human completely happy? What can make a human complete? These things are, therefore we have to, and that's why I brought up the idea of Jeet Kune Do. I know that this particular subject does not relate in any way or form with networking, and somehow it does. Because network is a relationship, it's a communication. It works, there's a harmony, there's messages being sent and forth, back and forth. It's what I'm doing right now. I am transmitting a message. Whoever receives it, they can or they cannot. Or my argument here is that, basically, my argument was that, or my claim was that, you have to approach problems in a very philosophical manner. You have to be very thoughtful. You have to be very engaged in it before you proceed. That's what I do with my with the problems that are before me. Because in the past few weeks I've been struggling with school. If you really, my thoughts have, with being prudent. I know that I do not have, nor will I be able to pass. The amount of information is so massive. The amount of data is just way too much, and for me it was very difficult to understand. And I was also going through a very difficult time in my life, and there was a lot of things I did not understand why they were happening. I was very unhappy. It was only until I learned about philosophy, the Socratic attitude, method of the need to understand life. And we have to approach that in the same manner when we come here, and we have to learn computer processing or computer networking, because they follow real world mechanisms. In my last video I talked about the domain name system, which follows how it can relate to the protocols that are used in air transport, in airlines. Yes, it's very frustrating. Basically, my thing is right now is that I've made a lot of mistakes in my life because I believe that there was a utopia. The thing is, there's no such thing. There's just, what needs to happen is a course of action. We need to act. We have to solve problems, because there will always be problems. Think about it. You have a created universe. Why are there problems? Why are there frustrations? Why are there glitches in the system? How can it be? How can we have a universe that seems to be in perfect harmony, yet there is trouble in our lives? Those questions are very deep, meaningful questions, and those things we have to ask, because that's the only way we are going to understand when we are faced with very difficult problems, especially problems that some people don't even relate to. For example, we just want to go on the web, send data over the internet. We don't really want to know the inside workings of the computer networking, but in my case, as a computer programmer, and because I want to be a full stack developer, yes, it is something that I had to know. But anyways, so that's my whole spiel, my whole thought on the subject. Nevertheless, what my point is, there will never be peace. And if you do want peace, you have to fight for it. You have to understand it, how life works. We have to understand that things do not go our way. It will never will be. We will always have some sort of social structure, some unfair system involved here. Are we going to act? Are we going to try to solve this problem? Can we look at the problem at a philosophical manner? Can we ask the right questions? Well, we can put that in practice right now. So let me get started and bring up my subject here. The network data layer. And in my past videos, I've talked about the different layers of networking. We have a protocol stack, which allows the computer these are protocols. These are what you call human manners, very similar to human, the way we speak to each other. There's a format. Well, the internet has a format that it must follow to be able to discuss, to send data, whatever it is. And it has a method of doing it. There's what we call the network layer, which is pretty much the glue of the whole system, how the internet works, how computer networks operate, how they send messages is through the network layer. Of course, there are more protocols. I covered it in my last videos, but in this video we're going to be going in depth to the network layer, which provides, I believe, the IP addressing. I believe it's the delivery system for IP packets. That's what its purpose is. So I'm just gonna go through this PowerPoint real quick and basically review it again. I'm a student as well. I'm trying to figure out how this works. and I'm coming here without any a priori knowledge of what's going on. Here we're going to be covering the IP Internet Protocol, its datagram format, IPv6 and IPv4, and some sort of different other factors here that I haven't reviewed. Let me go ahead and fix this a little bit. Okay, so we have here basically the internet architecture itself. The one circled is the IP, which is the network layer. Everything above and below are the different other layers of the protocol stack that I covered in my other video. Wi-Fi and the internet is your link layer. TCP and UDP is your transport layer. They're sort of like the addressing schemes. They're the ones that provide the address. Now the IP is the delivery system. It is what it provides the addressing capability so that we know where we are sending these packets, as you can see here. Multi-layer network protocol stack and the operating system, the different applications involved. And these drawing here shows us basically the topology. We can see in this image that the two different hosts have their own IP internet protocol, and also the routers, and they are sending this through the Ethernet interface. The routers are communicating through the SONET interface, and those packets are being sent to and fro. They have information. Then they go up the upper layers, your transport layer, which is the TCP segment and UDP datagram, all the way to the application. So the network layer is responsible for transporting segment from host to host. They encapsulate the segments into datagrams, and then they deliver the segments to the transport layer, and in the router it examines all the IP datagrams passing through it. So the network layer, it functions by forwarding the packets to the appropriate router. And let's see here. In this slide, it looks like it here it's sort of hard to understand. We have a problem with the routers. Yes, we can send the IP address, but how does it know where to send it to, which router? Basically, it has a forwarding table. That forwarding table has information about where it can send, which router it will send the packets to, so they can get to the destination. These routers have the information stored in them. It looks like that's what it does. It has it uses routing. Here we can see that the destination address, it takes the subnet mask only, so it doesn't have the network ID. It provides the proper subnet mask to determine where it's going to send packets. And it looks like the network's protocol is very quick. It has guaranteed delivery. It is in order. Minimum bandwidth, and it looks like it has congestion control. We have the IP header. So this pretty much covers all the slides for the network protocol. What I will do now is sort of open the book real quick. I always try to use a secondary source to look at the information. That was just a quick overview of what the network protocol entails. Let's see here, computer networking. Let's see here, the web transfer, peer-to-peer. As we can see here, the network layers, there's only in the host network, or we only have, like in the host PC, we have all the layers of the protocol stack. We have all the protocols. When it comes to the routers, there's only 3, and that's the network, the link layer, and then also the physical layer. So there's only 3. But it's important to note that network protocol is used in in all of these systems. Again, I just want to cover forwarding a little bit more. Basically, you have a router, the packet arrives, and the router must find a way to send that link to the destination, and the only way it can know that without any input from the host is to basically use a method called forwarding and routing. So it has the forwarding method, and then it uses the routing algorithms. Let me write that down. Networking. It utilizes forwarding and routing algorithms. basically what forwarding does is that it's a protocol that the router uses to transfer a packet to the proper output. And they compare this with driving, let's say, to another state like Florida, and the driver has to knows that there's many different routes to Florida, but he can use the process of forwarding to find the one way to get to Florida, pretty much. And we have here a forwarding table. The router uses a forwarding table, as I've mentioned earlier. What it does, it routes a packet by examining the packet's header, and using the header to basically figure out which it will try to match the data in the forwarding table to find out where to send that packet. Looks like they have a figure 4.2 here. So we can see here the value in the packet's header is 0111, which is I believe number 7 in the binary code. And number 7 here, the output link is the interface is number 2, so it will send it to the second route. That's pretty much how the interface works. So we have to note that there are two functions of the network layer. It is to forward and route. So it's like a delivery system. Whereas you have the transport layer, which was the UDP TCP was to provide the addressing. This provides a delivery system so that we can send one packet to the source to destination. So this is some of the services of the network layer. What the network layer guarantee is that basically guaranteed delivery. It has guaranteed bounded delay. It has in-order packet delivery, meaning those packets are going to be sent in order that they were sent. Minimal bandwidth. It also provides security services. Like TCP UDP, it did not provide I believe some sort of security for these packets, so the network layer does that. Here are the different network architecture. One of them is the internet that we are familiar with. The internet uses the best effort method, but I don't think we discussed this. I'm gonna actually make sure that this was discussed for the test. I don't want to cover extra material which hasn't been covered yet. we are now, let's see, 30 minutes into this broadcast. Stream. So we want to be familiar with network topology. We also want to be familiar with performance. We want to be familiar with IP, end-to-end, how it works. So we talked about the forwarding table, how it does that. So basically what I'm going to do now, just to get a grasp on the networking, is basically pull up an exercise here. I am showing this video to one of my peers. They're going to be looking at this, so it's very good that I should cover a little bit more. See if I can pull it up. Ooh, I don't have it pulled up. That's kind of. Let's run 4.2. What's inside the router? So there's some couple of things here that we didn't go over. But I'm going to go ahead and pull up the exercise for networking. Dun, 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 dun. Principles of operating system. We're going to have to talk about that. We're going to be going over that on Tuesday. Programming assignment and Weierstrass analysis. Network performance. Okay, so there's actually more slides here. Cool. I'm going to go ahead and download that. Alright, so there's additional information that I have to cover. So this sort of gets more in depth with the IP networking. I thought there was not. I thought all the data was covered, but it's not. So it's a continuation of the subject here. The networking data line format. Let's see here. So the same thing we were talking about this. Here we talk about the addressing in the U.S. I guess we're going to go over this because it relates to, I guess this relates to networking. Addressing in the U.S. Use zip code. We have the address of the building, the room in the building, the name of the person, and how do they forward the U.S. mail. Like I said, the network layer, the network protocol is like the delivery service. So we're kind of here using the addressing scheme of the postal service. Basically, they deliver by zip code, and they drop it off to the proper building in Rome, and then they give the letter to the appropriate person. So it's very similar to and the IP addressing. How does it work? So IP addressing, the IP address consists of 32 bits. So that's 32 bits. And they have a dotted notation. Each network interface has an IP address. So as we can see here that each section of the IP address holds about 255 bits. So that's the numbers that are represented in bits. So what we see, the IP address is represented as decimal. It's actually, it holds is bits. So with IP addresses, 32 bits, you can get a total of 2 to 32nd addresses available. Which is about, looks like 4 billion IP addresses available with this with this network protocol. And the IP address cannot be assigned randomly. They follow a format in giving IP address. So this, I think the slide is going to go over that. So what, you can't give this IP address randomly. They're not random. I believe each ISP are the ones that gives you they're going to go over its subnet mask. But the way they do it is that the IP address, like everything else in networking that we covered so far, follows a hierarchical structure, and they are assigned by organization. For example, NGIT has the subnet of 128.35. I don't know who these people are calling me. Alright, and the first 16 bits indicates that it's NJIT, and then the lower 16 bits of the IP address are going to be your different hosts, or different so the host will have their own addresses, looks like here. I'm not sure what this really does, but anyways, this is the LAN network. But yeah, here we are. We're talking about the subnet mask. Subnet mask. So basically, the IP address has a subnet mask, which is the first 16 bits. It might be 24 sometimes, but in this case it's 16 bits, but the first 16 bits are the network, and that is what we strip using the subnet mask to determine which one's the host. Which one is the network. Again, you can look more over into this, how what the subnet mask is, and IP address, and which one is the host. In this case, we have a 25-bit subnet mask. Let's see here, we have, so this one just goes over the same information. We have 32-bit IP addresses, and this is topology. We can have a network here, 223.1.1.1, and as you can see here as 0.2 the host, and then we have 0.3 as your third host, and it connects to the router. This network right here, 223.1.1. That's your 0.1 subnet. This is your second subnet on the right. On the bottom, you have your third subnet. I just call it subnet. And the last number indicates the host. Of the router, you have interface 27, 9, and 4. Again, the subnet mask is your high order bits. The lower part is your host. So here it says, what is a subnet? The high order bits. And they can physically reach each other without a router. Okay. With the subnet, they can reach each other without a router. So that's very important to just take note of. Let me go ahead and look at this slide a little bit more. They look at some address allocation. These addresses allocated by, looks like IANA, and then it branches out to these different continents like ARAN, which is North America. Then you have Afrinic, which I assume the African continent. So then you have LACNIC and RIPE, which is Europe. So they allocate this ISP. They're considered the tier 1, and then they allocate IP address to your tier 2 all the way to your computer. So how does a host get an IP address? Basically, they have to connect to the ISP. They have to get an internet provider, and so we can see these different organizations have their own subnet. You can see the last 16, let's see here, 24, 16. The last bits here indicates the organization. Wow. I think this goes into more in-depth operation. Of the routers. We can see here that there's a queuing involved when we are sending packets to the router. It has a datagram buffer. When the queuing gets when it becomes full, you can have a packet loss. And then we have a equation here. Hierarchy is the keys to scalability. And apparently the internet today has 400,000 prefixes. So some of those terms I don't think I mentioned properly. Again, this is kind of the first time I'm being exposed to this different structures. This one I'm going to look at the link layer. Oh, okay, I'm not going to look at that. Basically, this is the LAN, which I don't think I'm going to cover. Let me just look at my syllabus here. Okay, so basically, yeah, it looks like I do have to know this. how do you determine an interface MAC address? Basically, it uses the ARP protocol. It sends a broadcast of a query, and it will find the MAC address, and it stores it on a cache. This is the ARP format. We are now, let's see, 45 minutes into the video. So basically, the question here is, how do you get the MAC address from a host? Well, we use the protocol, the ARP protocol, which stands for let's see here if I can find it. Uses an ARP table. The ARP broadcast query packet containing the IP address. We know that they store the information in a cache. They use the target IP. So basically, all this is saying is it uses the ARP protocol. The question is, what is the difference between LAN and ARP? We're going to have to look at that because this looks like it deals with the link layer. Specifically for this video, I'm focusing on the network layer, which is your IP address. Looks like I'll just cover that in a few. On my next video, we'll look at the link layer a little bit more. So pretty much this sums up. I'm going to wrap it up. Again, we covered the network protocol, which makes it possible to basically, it is the glue that of the internet. Basically, we just have to know what the subnet mask is, what the network and the host parts of the IP addresses are, and I think that's pretty much it. The next video is going to be about the link layer, looks like, the link protocol, your ARP, and how do we get MAC addresses of the computer, what's a MAC address. I'm going to go ahead and end this stream and upload this on YouTube. If you have any questions or any comments, just write down on the feel free to comment. I'll also link Discord on the description.